Now we are continuing exercise 14.3, problem number 3. In this question, we have given distribution of ages of 100 policy holders of a life insurance company, and the policies are given to persons having age above 18 and less than 60. We have to compute the median of this frequency distribution table. Okay, so that means we have given the ages of 100 policy holders, and these policies are distributed among people having 18 age above and less than 16 years. Okay, see children, here it is a different problem, okay, other than the previous question. Here we have this frequency distribution of below 20, 25, 30 up to 60, and its corresponding cumulative frequency is given. That means this distribution is less than type. Okay, and the last column we have given the cumulative frequency of this frequency distribution. Okay, so in order to compute the median of this frequency distribution table, okay, what is the formula of median? Median is equal to L plus n by 2 minus Cf divided by F into H. That means here L indicates the lower limit of the median class. That means we have to convert this in the form of class interval form, and there F denotes, in the formula F denotes the frequency of the median class. Okay, so we have to find out the normal frequency and the corresponding class interval, and we have to locate the median class so that all the entries can be easily substituted in the median formula. Understood children? That means in short we have given less than type and its corresponding cumulative frequency. So first step is to convert this into class interval form with its frequency. Okay, so first I am going to find out the class interval Ci and its frequency. Here this is the cumulative frequency, that is the frequency given. Okay, so here it is clearly mentioned the question, policies are given to persons above 18 years, okay, and below 60. Okay, and here the numbers after below in the less than type, in the class interval, these are the values of its corresponding upper limit of the class interval. That means here 20, 25, 30 up to 60 are the upper limit of the required class interval. That means we have to find out the lower limit. Okay, that means this 20 is the upper limit of the first class interval. Okay, since it is the policies are given to the persons above 18, so we are talking about the people who have already completed 18 years. Okay, so we can write here 18. Okay, age bar from 18 to 60. Okay, so 18 to 20, and here the second class interval, this 25 is this upper limit. Okay, so this 20 is the lower limit. Okay, so that we can complete all the class intervals. Okay, so here it comes 30 is the upper limit, 25. That means here we are talking about the persons having age limit between 25 and 30. Okay, so 35 comes the upper limit of this class interval and 30 is the lower limit. Here 40 comes the upper limit, 35, here 45, 40 lower limit, here 50 is the upper limit, 45 is the lower limit, and in the next class interval, okay, so that we can easily complete the class interval form. Okay, from this less than type we will have now the class interval form. Next step is we have to find out its frequency. Okay, so what is cumulative frequency children? Sum of the frequency of that class with its corresponding, its preceding class. Okay, and also we know that in the cumulative frequency column, the first entry, the cumulative frequency is same as the frequency of the first class interval. Okay, that means 2. Okay, and in the second cumulative frequency 6 means, okay, it is a sum of the frequencies of first class and the second class, isn't it? But what we need the frequency of the second class. That means you have to subtract 2 from 6. Okay, that is 6 minus 2, 4. See, these two sums gives the cumulative frequency of the second class interval. Hope that idea is clear. Likewise, okay, this 24 is the sum of these three frequencies. Okay, or if you subtract 6 from 24, okay, you will get the frequency of the third class interval. Okay, that means you will have here 18, 24 minus 6. Okay, and 45 is the cumulative frequency of this 3 plus this fourth class interval, or you subtract 24 from 45, that is 21. Okay, likewise 78 minus 45, that is 33. Okay, 89 minus 78 will give you the frequency of this class interval 40 to 45, that is 11. Okay, and here it comes 92 minus 89, 3. Okay, and 98 minus 92, 6. Here comes 2. These are the frequencies of the given class interval. Okay, that means we have converted less than type into class interval form, and we got the frequency of the corresponding class interval from its cumulative frequency. Okay, median is equal to L plus n by 2 minus Cf divided by F into H. Okay, here in the frequency distribution table, we are talking about the 100 policy holders. That means sigma Fi or small letter n is equal to 100. Okay, so in order to locate the median class, okay, find out n by 2. N by 2 being n is equal to 100, n by 2 is 50, 100 by 2. Okay, and in the cumulative frequency column, okay, that is that cumulative frequency just greater than n by 2, that is 50, here that is 78. Okay, and the class corresponds to this 78 cumulative frequency, okay, which is just greater than n by 2 is the median class. Okay, so the median class is here 3540. Okay, and here 33, that is the frequency of the median class. Okay, and this is F. Okay, and this 45, that is cumulative frequency of the class preceding the median class, and this is CF. Okay, and H is equal to the difference between upper limit and the lower limit, that is 40 minus 35 is 5. Okay, so we are going to substitute all these values in the given equation, that is L is lower limit of the median class 35 plus in the bracket n by 2, 100 by 2, n is 100, so 50 minus CF 45 divided by F, that is 33 frequency of the median class, into H, that is 5. That is upper limit minus lower limit. Okay, and 35 plus 50 minus 45 is 5. 5 divided by 33 into 5, this 5. Okay, so 5 5s are 25 divided by 33, that is 35 plus 5 5s are 25 divided by 33. Okay, we can divide 25 with 33. Okay, so 25 divided by 33. Okay, since 25 is less than 33, we have to put 0 and at the same time decimal point in the quotients place. And 33 into 50. Okay, 33 into, can we take 7, 21, 2 carries 23. Okay, 21 plus 2. That is, yes, 7, 2, 31 On subtraction you will get 19. Okay, we can find out the decimal places, 3 decimal places. Okay, so 0, already we put decimal point there. Okay, so 33 in 190. Can we take 5? Okay, 15, 1 carry 60, that is 165. Subtraction, so 5, 25. Okay, and we can add 0, one more decimal place we can find out, and 250 we already have seen that is 5 times. Okay, it's not 5, 7 times, that is 231. Okay, it will continue like this. We need only up to 3 decimal places, and so that we can round off to 2 decimal places. Okay, since here this third decimal place is 5 or above 5, you can round off to 2 decimal places by adding 1 to the second decimal place. So that is 5 becomes 6. That is 35 plus 0.76. Here 7 become 6. Okay. So median is equal to 35.76. This is the age, average age of this 100 policy holders is 35.76 years. Okay, now we are moving to the fourth problem. Now we are solving the fourth question. In this problem, we have given length of leaves of a plant are measured in millimeters. Okay, that means these are the length of 40 leaves of a plant. Okay, and we have to calculate the median length of the leaves. Okay, so these are the number of leaves whose length falls between this measurement. We have to find out the median length of these leaves. Okay, as usual we can check whether this is continuous. Okay, if it is continuous, we can apply the formula for median, that is L plus n by 2 minus CF divided by F into H. Okay, see the class interval. This is very important problem. Yes, children, here 118 minus 126, and in the second class interval starts from 127. That means the upper limit of the first class interval and the lower limit of the second class interval are not the same. That means the given distribution is not continuous. Okay, so in order to substitute these values in the given equation, that median formula, that a class interval must be continuous form. Otherwise, we have to find out the adjustment factor. Okay, that I have given a detailed explanation of this adjustment factor, or how to convert discontinuous form into continuous frequency distribution. Okay, so see the difference between this lower limit of the second class interval and the upper limit of the first class interval. If you are taking the third and fourth, okay, see the fourth class interval, it's the lower limit and the upper limit of the third class interval. Okay, and take its half. That means 127, that means the lower limit 127. Okay, adjustment factor, we have to find out adjustment factor, that is equal to 127 minus 126 divided by 2, that is 1 by 2 or 0.5. This is adjustment factor that should be added with each upper limit, and that 0.5 should be subtracted from each lower limit, so that you can easily convert this frequency distribution, that is discontinuous form, into continuous form. Idea is clear, children? Here the upper limit and the lower limit both are the different numbers, are not coinciding. That means this is discontinuous form. Okay, so in order to make it continuous, find out the adjustment factor by subtracting this upper limit minus lower limit, okay, and divided by 2, that is 1 by 2, 0.5. That should be added with each upper limit, and 0.5 should be subtracted from each lower limit. Let us see how this is going to how we can convert this into continuous form. Okay, that means 0.5 should be subtracted, that is 118 minus 0.5 is 117.5. okay, and 0.5 should be added with each upper limit. So 126.5. So this is the actual class interval, okay, class interval. Then again I am subtracting 0.5, that adjustment factor, from the lower limit of the second class interval. So it becomes 126.5 and I am adding 0.5 to its upper limit. Likewise, you can make easily this into continuous form. 135.5, 144.5. Okay, again 0.5 from 145, that is 144.5. See, both are the same. 153.5 we are adding. Okay, 153.5 we are subtracting 0.5 from 154. 162.5, 162.5, 171.5, 171.5, 180.5. Okay, so we have converted this into continuous form by finding the adjustment factor, and each class interval add the adjustment factor with its upper limit and subtract the adjustment factor from its lower limit. Okay, and since we are finding the median, okay, that means we have to find out the cumulative frequency. Okay, so only for median we are finding the cumulative frequency. For arithmetic mean and mode, that the cumulative frequency is not needed. Okay, so cumulative frequency of the first class interval is the frequency itself, that is 3, and the sum of this 3 plus first class interval and the second class interval will give you the frequency of these two, will give you the CF of the second class interval, that is 8. Okay, 5 plus 3. Okay, and if you add, this will be 17. Okay, and 29, 34. Okay, 38. If you add 2 with 38, that means that 40. The cumulative frequency of the last class interval will be the sum of the frequencies of all the preceding classes plus frequency of the last class interval. The cumulative frequency of this class interval will be sum of the frequencies of all these preceding classes, that is 34, plus the frequency of that required class interval, that is 4. That is how it becomes 38. Likewise. Okay, so now we have the cumulative frequency column, and we are talking about the length of 40 leaves. Okay, that means here small letter n, the sum of the frequency is 40. So n by 2 is equal to 20. That means in order to locate the median class, we have to find out n by 2. Okay, and in the cumulative frequency column, see that the CF just greater than n by 2. Okay, so n by 2 being 20, just greater than 20 is 29. That means this 144.5 and 153.5 is the median class, and the frequency of the median class is F, that is 12. Okay, and CF is the cumulative frequency of the class preceding the median class. Here, since this is a median class, so preceding class its cumulative frequency, then this is CF. Okay, and we can write down the formula. Okay, that means median is equal to L plus n by 2 minus CF divided by F into H. Okay, now we are going to substitute these values, okay, in this given equation. That means we have already seen what is L, that is lower limit of the median class. Okay, that is 144.5 plus n by 2 20 minus CF. Okay, CF of the class preceding the median class 17 and frequency of the median class 12, and how that H is equal to, this is actual class limits. Okay, upper limit minus lower limit. Okay, that means we can find the difference 153.5 minus the lower limit 144.5, that is 0. we can borrow and it will be 9. So, H is equal to 9. Okay. So, we can substitute here, that is H as 9. So, the substitution is clear, children. Okay. We have to find out upper limit minus lower limit from the continuous form. That means this from this table. Okay, these are the actual class limits. By subtracting the adjustment factor and adding the adjustment factor with its upper limits, you will be getting the actual class limits. Okay, then take their difference and that will give you the height or the class width. Okay, now the final calculation. 144.5 plus 20 minus 17 is 3 divided by 12 into 9. Okay, and 3 in 12, that means 4 times. Okay, 3 in 3 one time, so 9 by 4, that is 144.5 plus 9 by 4. We can divide 9 with 4. Okay, 2 times. Okay, and in 10 again 2, that means 8, and in 20 5 times. Okay, remainder 0, that means 144.5 plus here 2.25. Okay, decimal. So, we can add here 144.5 plus 2.25. Okay, so that we can make here over 0. So, 5, 7, 6, 2 plus 4, 4, 1. Okay, that means 146.75 and the length of the leaves is in millimeters. So, this is the median length of this 40 leaves. Okay, if you arrange the leaves, the length of the leaves in ascending order or descending order, this will comes in the middle. That is the meaning of median of the frequency distribution. Okay, this is all about the fourth question. Now we are moving to the fifth question. Now we are solving the fifth question. Here in this fifth question, we have given the lifetime of 400 neon lamps. Okay, we have to find out the median lifetime of a neon lamp. Understood? Okay. So, since it is a class interval form, first we can check whether it is continuous. That means the first class interval upper limit and lower limit of the second class interval are the same. Likewise, all the class intervals, that means this is a continuous frequency distribution. Okay, if it is continuous, the calculation will be very simple, no need to find out the adjustment factor and all. Okay, and directly we can move to the cumulative frequency column. Okay, that means in order to compute the median, we have to find out the cumulative frequency. Okay, cumulative frequency, we know what is cumulative frequency. The cumulative frequency of the first class interval is always the same as the its actual frequency, that is 40. Okay, and the second class interval, its cumulative frequency is the sum of the previous class interval and its frequency of the cumulative frequency of the required class interval, that is second, that means 56 plus 14, that is 70. Okay, and this will be sum of these two plus 60, that means 130. Okay, this 130 sum of these three frequencies and plus this required class interval 86, that is 216. This is the cumulative frequency of the fourth class interval. Okay, and if you add this frequency with the sum of the four class frequencies, you will get the cumulative frequency of this one. Okay, that means 290. Okay, and 290 with this 62 will give you this cumulative frequency of this class interval, that is 352 plus 48, that means will give you 400, and that will be same as the number of neon lamps, that is 400. That means our cumulative frequency column is correct. Okay, and the next step is we have to locate the median class. Okay, for that find out n by 2. N by 2 is 200. And in this cumulative frequency column, okay, the cumulative frequency just greater than n by 2, that is 200 here, and the class corresponds to this class interval. Okay, this cumulative frequency, this class interval will give you the median class. Okay, and this frequency of this median class is f, and the cumulative frequency of the class preceding the median class. So 130 will be the CF, and h is equal to upper limit minus lower limit. Okay, that means 3500 minus 3000, that is 500. Okay, then what is median by formula? Median is equal to, okay, median is equal to L plus n by 2 minus CF divided by F into H. Now we have all these values of the required formula. Okay, so we just substitute and we will get the average, not average, median lifetime of a neon lamp. Okay, so lower limit is equal to 3000 plus n by 2 in the bracket 200 minus CF 130 divided by frequency of the median class 86 into H is 500. Okay, so in the bracket we can keep 3000 without any change. By subtracting this 200 minus 130 is 70 divided by 86, this 86 into 500, okay, 500, okay, that is the height h. So 7 5s are 35, that is 35 with how many zeros? 3 zeros. Okay, that is 35,000 divided by 86. That is what we are going to do in the next step, that is 35000 divided by 86. We can start with the 350. Okay, so in 350 what can be taken? Can we take 4? If we are taking 4, 24, yes, we can take 4, 24, 2 carries 32, 34. Here 30, 350, so 4, so 344. Subtracting, you will be getting 6. And we can bring down this 0. Okay, see children, this after bring down the 0, now we have 60 and this 86 and 60 less than this number. Okay, so we have to put 0. And in the next step you can bring down the last 0, that is now the 60 becomes 600. And which number we can take? Can we take 7? 7? No, we can't take 7, we can take 6 only. Okay, that is 36, 3 carries 48, 8 6 are 48 and 51. Okay, that means here 6 comes. 516. Okay, you will have 4 and 84. Okay, and next I am going to put 0 decimal point here over here and 840. Okay, 840 you can take 9. Okay, so in 9, 54, 5 carries 72, 77, isn't it? So you can take 9 after the decimal point, 774. Okay, so subtracting 6, 6. Okay, we have borrowed from here. Okay, now you have what is it? 66 as a remainder. One more 0, that is 660. We can round off to 2 decimal places. For that we have to see the answer up to 3 decimal places. Okay, so here 9 comes 700 and so we can take 7, right? So if we are taking 7, 42, okay, 4 carries, yes, then 56, 60, okay, then 7, 602. Okay, you will have 8, 58, one more place. 580, 580 you can take definitely 6. Okay, 6, 36, 3 carries 516. Okay, so 516, that is 6 times 516, this is enough, so 6. So after dividing this 35,000 with the 86, we have reached into 406.976. Okay, we can round off. Since the third decimal place is 5 or more than 5, you can add 1 with the second decimal place. So this 7 become 8. That is 3000 plus, okay, 406. Now we are solving the sixth problem. Here in the sixth problem, we have given 100 surnames are randomly picked from a local telephone directory, and the number of alphabets in the English alphabet of each surnames are given in the frequency distribution table. Okay, and we have to find out mean, median and model of this frequency distribution. That is, all the three we have to find out. Okay, so first we can find out the arithmetic mean, and also we have two methods, and I am going to take assumed mean method for getting arithmetic mean of this frequency distribution. Okay, so and here first we can check whether this is continuous. Okay, 4, 7, 10 and 13, 16, 16. So this frequency distribution is continuous, and the class size. Here the class size is 4 minus 1, upper limit minus lower limit, that is 3. And for each class interval, the upper limit minus lower limit is 3. That is, the class size is 3. That means in the mid value column, that is in the third column, the difference between two consecutive mid values also 3. Or you can find out the half of the class size, that is 3 by 2, that is 1.5, can be added with the lower limit of each class interval. These are the different methods to get the mid value. Okay, that is 1 plus for upper limit plus lower limit divided by 2, that is 5 by 2 is 2.5. Okay. In order to get to 2.5, the second method is the difference is 4 minus 1 is 3. 3 by 2 is 1.5. That 1.5 should be added with the lower limit. 1 plus 1.5 is 2.5. See here also, here 4 plus 1.5, that is 5.5, or 4 plus 7, 11 by 2, 5.5. Okay, 5.5. Or the third method is you can add 3 with each preceding the mid value. These are the different methods. Any which you feel easy, that can be adopted. Okay, so 8.5, okay, 11.5, here 14.5, okay, 17.5. These are the mid values. After this mid value, writing the mid value, we can select one from this third column, and that will be the assumed mean, almost the middle of this observation. Okay, so I am here, you can take either 8.5 or 11.5. So I am taking 8.5 as assumed mean. Okay, that means assumed mean A is equal to 8.5, and deviation xi minus A. So that you can easily write 0, because 8.5 minus 8.5 is 0. Okay, and all the entries above this will be negative and below will be positive, and being the difference is 3, multiples of 3. Okay, see 8.5 minus 5.5, okay, minus 8.5 is minus 3. Okay, here it comes 6, that is minus 6. Okay, 2.5 minus 8.5. Here you will, all the entries will be positive, that is 3, 6, okay, 14.5 minus 8.5, 17.5 minus 18.5 is 9. Okay, now we can find out Fi Di column, that is the last column, get the product of Fi with its corresponding Di, that is here again comes 0, 14 into 0. So negative 36, Here it comes 30 into minus 3 minus 90. Here positive 16 into 3 48. 4 6s are 24. Here 4 into 9 36. Next we have to find out sigma Fi di. Here sigma Fi. We are talking about 100 surnames. Okay, so that will be 100. Okay, then sigma Fi di. We can add all the negatives. Okay, so 6, 9 plus 3, 12, negative 126. Here you can add the positives. Oh, we can calculate, cancel negative 36 and positive 36. Okay, so you will have minus 90 alone. Here we have 12, 8 plus 4, 12, 1 carry, 6 plus 1, 72. Okay, so 90 minus 90 plus 72 is 18. Okay, so sigma Fi di is negative 18 and sigma Fi is 100. And what is assumed mean? By assumed mean method, x bar arithmetic mean is equal to a plus sigma Fi di divided by sigma Fi. Arithmetic mean we have selected as 8.5 plus sigma Fi di is negative 18 divided by 100. Isn't it? Okay, so it is very simple. If you are dividing any number with 100, you can shift the decimal point to the left by 2 decimal places. It is minus 8.5 minus 0.18. We are dividing with 100. Okay. So 8.5 minus 1.8. Sorry, 0.18. Okay, there is 0 in the whole number place, right? So we can borrow from here 2, 3 and 8. That means 8.32. This is the average letters in that surnames, that is x bar is equal to 8.32. Okay, next we are going to find out the median. Okay, so in order to get the median, okay, what I told already, we have to compute the CF, that is cumulative frequency of each class interval. We don't want these entries, that is xis and di column is not needed. Instead of that, we can complete cumulative frequency of each class interval. Okay, so CF. So CF of the first class interval is the frequency itself. Okay, so the CF of the second class interval, that is the sum of first and the second, that is 36. Okay, and 76. Here comes 92. 92 plus 4, that is 96 and 100. This 100 and the total frequency will be the same. Okay, cumulative frequency of the last class interval and the sum of the frequency must be the same. Okay, that means our calculation is okay. So the next step is we have to find out the median class. In order to locate the median class, here we have n. Sigma Fi is also n. N is equal to 100, so n by 2 is 50. Okay, so if n by 2 is 50, see the cumulative frequency column. Okay, the cumulative frequency just greater than 50 and the class interval corresponds to that will be the median class. Okay, 50, that means 76. So this is the median class. Okay, after locating median class, so the frequency of the median class is F and this is CF. The cumulative frequency of the class preceding the median class will be that is CF is 36 in this problem, and H is equal to 4 minus 1, that is 3, and the formula median is equal to L plus n by 2 minus CF divided by F into H. Okay, that means lower limit of the median class that is 7 plus n by 2 50 minus CF 36 divided by F 40 frequency of the median class and the height that is 3, h is equal to 3, upper limit minus lower limit. And there is no change for 7. We are simplifying this side only. That is 1450 minus 36, 14 divided by 40 into 3. Okay. So, you can divide here with the 2, that is 7, here 20, right. So, 7 plus 7 into 3, 21 by 20. Okay, now we are dividing 21 with the 20. One time, okay. So, remainder 1, we are adding 0, but still it is less than 20. So, you can put 0, okay, 0. Then you can add sufficient zeros, okay, 5, okay. So, 100, so remainder is 0, that is 7 plus 1.05, okay, that is 8.05 is the median of this frequency distribution. This is the median. Okay, it's very simple. In order to find out median, we have to first prepare the cumulative frequency column and apply, find out its median class. Then you can substitute in the given formula, that is median formula. Okay, and now we are moving to mode. Okay, so what is mode? In order to find out mode, we have to find out from the frequency column the maximum frequency, highest frequency. We don't want this cumulative frequency column. That is only for median. Okay, and we have located the median class, and for calculating mode we have to locate model class. That means the highest frequency and the class interval corresponds to that will be the model class. Okay, here from the frequency distribution 40 is the maximum frequency. So, the class corresponds to 40 is 7 to 80. So, the mode will lies in between that. So, this is the model class. Okay. And what is the next step? We can find out the formula, corrective formula, that is mode is equal to L plus F1 minus F0 divided by 2F1 minus F0 minus F2 into H. Formula clear, children? F1 minus F0 divided by 2F1 minus F0 minus F2 into H. Okay, here F1 is nothing but this frequency of the model class. So, that is F1, okay, and F0, the frequency of the class preceding the model class. This is F0 and F2, okay, this comes after the model class. This is F2. And height is equal to again upper limit minus lower limit, that is 10 minus 7, that is 3. Okay, and next part is just substitute these values in the formula, that is L lower limit 7 plus F1. F1 is 40 minus F0 30 divided by 2 into F1 40 minus F0 30 minus F2 16, okay, into 3. Height is 3. Okay, and I am keeping 7 without any change, and I am solving the bracket first. 40 minus 30, 10 divided by 2 into 40 in the denominator, 80 minus 30 minus 16 minus 46, add and give negative sign, 46 into 3, right? Okay, here 80 minus 46 will be 34, 80 minus 46, we can borrow 4, okay, then 7, 34, okay. So, in the next step I am going to multiply the numerators, okay, that is 7 plus 10 into 3, 30 divided by 34. Hope this step is clear, children. Okay. So, we can be both are even numbers, you can divide with 2. So, 15 divided by 17. Okay. So, we can divide 15 with 17. Since 15 is less than 17, we can put decimal and we can add 0. And in 17, can we take 8? Okay, 56. Okay, 5 carries. Okay, 136, right. Okay, 136. So, 14 is the remainder. Okay, and we can add 0. Okay, in 140 we can take again 8. Okay, we already have seen 136 and remainder 4. We can find out one more place value, that is 40. Okay, so 2 times. Okay, that is 34, and since that third decimal place is less than 5, we can neglect that third decimal place. That means 7 plus 0.88 or 7.88 is the mode of this frequency distribution. Okay, so this is all about this sixth problem. We have seen all the 3 center tendencies, that is mean, median and mode. Okay, now we are moving to the last problem of this exercise. Now we are moving to the last problem of this exercise, that is the 7th question. Here this frequency distribution shows the weight of 30 students of a class. We have to find out median of the weight of this frequency distribution. Okay, quite simple question. Okay, so since it is distribution continuous, first we can check whether it is continuous. Okay, yes, upper limit and lower limit of each class interval are the same, that means this is continuous. Okay, and since it is median, we have to first prepare cumulative frequency column. Okay, that is CF. Okay, and both the frequency and the cumulative frequency of the first class interval will be the same, and sum will be you will have the second cumulative frequency of the second class interval, and if you add 8 with this sum, that is 13, and 9 with the 6 with the 13, 19, and 6 with the 19, 25. Okay, 28 plus 2 and 30 will give you the cumulative frequency of the last class interval, and that will give you also same as the total number of students in the class, and that can be represented with the n. That is given. We are given the weights of 30 students of a class. Okay. So, first step is to find out or locate the median class. For that, n by 2. Here n by 2 is 15, and in the cumulative frequency column, the cumulative frequency just greater than n by 2, that is 15 and that is 19. Okay, and the class corresponds to this 19 will be the median class. And the lower limit is 55, and the frequency of the median class is f, and the cumulative frequency just greater than the median class, above the preceding the median class will be CF. Okay, and we can substitute these entries, these values in the formula. Median is equal to L plus n by 2 minus CF divided by f into h. Here h is nothing but upper limit minus lower limit, 60 minus 55, and that is 5. Okay, lower limit of the median class is 55 plus n by 2, 15, 30 by 2, CF, cumulative frequency of the class preceding the median class, and that is, we have seen that 13 divided by frequency of the median class is 6, and height is h. 55 plus 15 minus 13 is 2 by 6 into 5. Okay, 2 by 2 in 6, 3 times, that is 5 by 3, 55 plus 5 by 3. Now we can divide 5 with 3. Okay, 3 in 5 one time, remainder 2, and in 20, okay, that is 6 times, so 18, 2 again 20 comes because the denominator is 3, the division will not terminate. Okay, so again 6 likewise, 18, again 26, 6 like. Okay, so 55 plus 1.67, we can round off to 2 decimal places. Okay, so the final answer will be 56.67 kg. This is the median weight of that 30 students of a class. Okay, so this is all about 13.3. Very important problems we have discussed. Okay, missing frequency problem can be expected for the board examination, and or other than that, median or mean median mode of a single problem. Okay, so this exercise is very important, but it is quite simple exercise, and you have to learn the formula so that you can easily simplify the problems. Okay, thank you children, thank you all for watching and supporting my channel. Thank you all.